And once again, you should have gotten 2 blank sheets of paper, 1 index card for the graphing, and you have your study guide 5A. Also, by now you should have already IM, kicked, snapped, WASP, or whatever it is you do. So put away the electronic devices. If I see them out, or if I see you peeking, like some of you do, I'm going to take it away 2 weeks. Just letting you know. All right? So, before we get started, I just want to clarify a couple of things in regards to parallel and perpendicular lines, and then we'll move on to the study guide. So on your blank sheet of paper, I want you to write at the top, parallel and perpendicular. Oh, let it go. Let it go. Let it go. Perpendicular lines. If my computer doesn't fail, I'm going to try and record the session into 2 sessions. The morning before the break, I'm going to try and upload that, especially for those of you that couldn't make it and that are at the robotics competition. But for those of you that are going home to review this, make it a math movie night or something, it's going to be on the YouTube channel, okay? All right. Y'all ready? All right, do me a favor, get your index card folded in half, hot dog style, hot dog, not hamburger. Tell your neighbor what that means. Hot dog, not hamburger. Oh my goodness. Hot dog is lengthwise, hamburger is, yeah. Tell your neighbor how it is. All right, here we go. So, the way you fold it, that index card, now you have a hard edge on one side and 2 edges on the other. The hard edge will be your ruler or your straight edge to sketch line, okay? So, first things first, let's sketch 2 parallel lines, like so. All right, so before we continue, there are certain characteristics that we want to talk about in regards to parallel lines. So before we do anything else, turn to your neighbor, let them know what you know about parallel lines. Oh, okay. I think I got it. Yeah, and the thing is, all right, for the next one, email me. All right, let's see. Robert, go. What's that? They are the same as each other. All right, I'll take that. Justin, never touch, or in other words, never intersect. Ryan, same slope. Okay. Question, if they never touch, if they have the same slope, what does that mean that they never touch? If we graph them, what does that mean in their position on the graph? Tell your neighbor, please, what does that mean? Mia, L, go. Bam, they don't intersect. I didn't say that. I said if they never touch or don't intersect, what does that mean of their position on the coordinate plane? Yeah, that's why they're called parallel. They are parallel. Jason. That is correct. Different y-intercept. Are we there? So let's say, check this out, that I gave you the equation for this line right here. The equation is y equals 2x plus 23. Bam, from the corner. Tell your neighbor an equation, or actually first, before you tell your neighbor, write an equation for this line that's parallel to that one. Go. And it can't be the same one as your neighbor. Write your own. Oh my goodness. You write it down? Okay, let's see. Octavio, go. Y equals 2x plus 24. Hands if you agree with that? Yeah, and we can see how the 23 is above the 24. All right. Yeah, and they are parallel and they don't intersect. So give me another one. All right, Angeline, go. Y equals 2x minus 12, and so on and so forth. We got this, yes? So once again, what's so important about writing parallel lines? So your neighbor, what would be two imperative things? So your neighbor, what are two imperative things about writing parallel lines? All right, Connor, go. What's two important things that we need to know about parallel lines? Writing equations, parallel lines. No, about writing equations that are parallel or parallel lines. Same slope. What else? Different y-intercept. Hands if you agree with those two? Yes. So that's imperative for that. All right. Let's move on to perpendicular. So those were, let's label this parallel. And if you notice in the word parallel, there's two parallel lines. You guys know? Or three with that last one. Bam. Perpendicular lines. All right, so check this out. Draw this one like this. If you have your colors, I'm going to sketch the other one a different color in blue, like so. All right. So, talk to the neighbor and let them know what are the things that you know about perpendicular lines, for sure.
They are lines.
Woo! Man, you guys are lively today on Saturday. They are lines. Thank you, Mia A. Let's see. They're not parallel. Wow, man, you guys are enlightening today. So they are lines, Not parallel, okay. They are used in math, yes. Create, right, yes, angles. They create right angles. What does that mean? They have 90-degree angles. Hold on. So, this is all true. So, let's go with this last one. So, to identify that they create 90-degree angles, this is what you would do. Label this with a little angle here, angle here, angle here, and angle here. All those four are 90-degree angles. 90-degree angles. All right. Bless you. Okay? So, I'm going to give you an equation for this line. Pay attention. Ready? Y equals 2x plus 23. Okay? So that's this line. I want you to think about the equation, now that we covered this, of this line. Y equals blank, x blank. Talk to the neighbor, let them know what the slope is and what is the y-intercept of that equation for the perpendicular line there. All right. Fatima, what'd you get for the slope? Be nice. She said negative 1/2 x. Hands if you agree with that. That is correct. We need the last part. Help her out. Go ahead, Daniel B. Plus 23. It's not impossible. So, before we move on, your neighbors probably forgot about something, but this is correct. Talk to the neighbor, let them know what makes this or these two perpendicular. What in particular makes them perpendicular? All right. Let's try Victor. What makes them particularly perpendicular? Their slopes are what? Reciprocal. Reciprocal and what else? Julian. Jason. Reciprocal, and then the second one is inverse. Write this down, please. Underline it. Slopes are reciprocal. That's the first thing that needs to be true. And the second thing that needs to be true is that they have to be inverse, and this is in regards to their sign. Inverse in regards to their sign. Yes, since we're on Saturday Academy, just get up and go. All right? So let's see. This is the only requirement for perpendicular lines. So if this is true, is this the only equation for this line? Talk it over with your neighbor, please. Talk it over with your neighbor. Scarlett, go. Is that the only equation for that line? No, because the y-intercept could be different. That is correct, and that is true. If that's true, give your neighbor another equation for this line, please. Go. Let's see. Isabella. What'd you get? One-third. And if you agree that this line is perpendicular to that one. Okay, tell your neighbor what needs to change about that one right there. All right, here goes again. I think some of you, either you got distracted or you didn't understand the two premises here. Here it goes again. This is our original equation. This is perpendicular to that one. Why? Because we said that the slopes have to be reciprocal inverse, but they not necessarily have to have the y-intercept. That is the same, so it could be different. So if that's true, let's see, Tanner, go. Plus 4. Hands if you agree that this one is also the equation for that line. Yeah, it could be, because it has to have the same, the reciprocal inverse slope, different y-intercept. Are we there? All right. Example Q, write this down. Y equals 3x plus 2. I want you to write me a parallel and a perpendicular equation to a line if we were to graph that. Go. Bless you. All right. Share what you got with your neighbor, please. All right, let's see. Reagan, a parallel line to that one. -1. Hands if you agree with that? That is correct. They need to have the same slope, different y-intercept. Okay. Pass it to someone. Tanner, a line perpendicular to this one. -1/3 x. What else? +2. Hands if you agree with that. All right. So far so good. Yes? Let's do another one. Example super cube. We got y equals negative 2/3 x minus, give me a number, 5. Once again, write me a parallel and a perpendicular line. All right, Nikki, go. Parallel line. Plus 6, and a perpendicular one. Minus what? Minus 5, okay. Hands, if you agree with those? Could we have a different y-intercept for the the perpendicular one? Yeah, it could either be the same or different. So just wanted to address that. But remember, reciprocal inverses. So show me with your fingers how comfortable you are with parallel and perpendicular lines. 5, 5, 5, 5, 5, 5. What? Really? 23, I like that. All right. So with that said, get your study guide in front of you. Study guide A. Unite. Problem number 1. It says, let me zoom in. Focus, please. It says, given the points 1, 7, and 2, 2, part A says, write an equation in slope-intercept form for the line that passes through the 2 points. So what is the key phrase here? Write an equation in slope-intercept form. All right, so what would be the first thing that your noodle tells you to do? That is correct. You need to write y equals mx plus b. So right away, 2 things that we need to write our equation is our slope and our y-intercept. Once again, if you have your colored pens, use those so you can label stuff. So, do they give us a slope? Do they give us a y-intercept? No. Therefore, let's start with the slope. What can we do to find our slope with a given information? Tell your neighbor, please. Okay, I heard everybody about the formula, yes? So we write m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. From there, the one step that you keep, some of you keep skipping is the formula, and then this next one, blank, minus, and minus. Some of you keep skipping those 2 steps, and guess what? When we are dealing with negative values, some of you make mistakes. So let's label our stuff. We got x sub 1, y sub 1, x sub 2, y sub 2. Okay? Here we go. So let's fill in our information. What is y sub 2? Y sub 2 is 2. What is y sub 1? Y sub 1 is 7. What is x sub 2? X sub 2 is 2. And what is x sub 1? X sub 1 is 1. All right, let's see what we get. 2 minus 7 is negative 5. And what is 2 minus 1? 1. So my slope is negative 5. What do we do with that? We substitute that underneath here, the m, so we write negative 5. Well, now we need a b. Do we have a b? No. But what other values do they give us that we can use? Tell your neighbor, please. What can we use? We can use an x and a y value. So we can either use this point or this point. Which one do you want to use? The 2's? No, I'm going to use the first one. So instead of x, we write 1. Instead of y, we're going to write 7. You could use also the other one. It doesn't matter, but as long as you stay consistent using 1 point. Plus b. All right, so then we have 7 equals negative 5 plus b What's our last step? Plus 5 plus 5.
12 equals B.
12 equals B. Do we have enough information now to write our equation? In slope-intercept form? Yes. So let's write that out. Our equation is y equals, instead of m, I'm going to write negative 5x, and at the end, plus 12. Show me your fingers how comfortable you are with this part. Okay, good. Let's go to part B. Look at part B. Write an equation in slope-intercept form that is parallel to the one above. Write your own, please. Go. A line that is parallel to the one right there. Don't copy your neighbor. Write your own. All right, share your equation with your neighbor. All right. Let's see. Yoann, go. Slope-intercept form parallel to that one. Y equals negative 5x. What else? Plus 11. Hands if you agree with that. Parallel? Yes, that is a parallel. All right? Let's go to the next one. Write an equation, slope-intercept form, that is perpendicular to the line above, which means this one. Write your perpendicular equation, please. I'm going to switch to red. All right, share with your neighbor your perpendicular. All right, let's see. Maya, go. Okay, you said y equals negative 1/5 x plus, what's that? Plus 15. Hands if you agree with that. Close. Tell your neighbor what needs to change on that one. It has to be a what? Positive. So let's take this negative away. Anyways, I can. All right. So yeah, so the reciprocal of negative 5 is 1 over 5, and the inverse of a negative is a positive. All right, now does everybody agree with that? All right, let's go to part D. Part D. It says, focus on this one. Write an equation in standard form for the line that passes through the 2 points, then identify A, B, and C. So pay attention to this part. Guys, focus. And Julian, be nice. It says, write an equation in standard form for the line that passes through the 2 points. What 2 points? These, right? Do we have an equation already for the line that passes through those 2 points? Yes, so let's get that equation and we write it here. We write y equals negative 5x plus 12. Because we don't have to do all the work again, right? But is that in standard form? No. Tell your neighbor what needs to happen to make it in standard form. Okay, that is correct. We need the x and the y on the same side of the equation, so we need to add 5x to each side. Add 5x to each side. We're left with 5x plus y equals 12. This is standard form. So now that we have it like that, let's write our form underneath. AX plus BY equals C. Remember those? Yeah, we did those on the first semester. Now we're trying to bring everything together. Now that we have this, is this looking like this? Yes, this is standard form. Standard form. So now let's do the last part. Identify A, B, and C. So A is equal to 5, B is equal to 1, and C is equal to 12. That is problem number 1 for the Parte for Monday, the whole thing. Let's look at this. Once again, we started with 2 points. We wrote our equation, a parallel, a perpendicular, then they wanted the original in standard form. Okay? Get your blank sheet of paper. You're going to do one completely by yourself. All A, B, C, and D. Ready? Here we go. Let me change the points. Here it goes. Points given are 4, 6, and 3, 8. 4, 6, 3, 8. And once again, guide yourself with the instructions of A, B, and C. A, B, C, and D. I want you to do all parts. Problem number 1, we're going to label this on our blank sheet of paper. Example 1Q. Go. All right, let's see. Here goes part A. First things first. Y equals mx plus b. We need a slope. We need a y-intercept. I'm going to start with a slope. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. M equals blank, minus, and minus. That is imperative. If you don't do those steps, you might get a mistake because of negative values later. From there, we label our points. X sub 1, y sub 1, x sub 2, y sub 2. Are we there? Next, let's substitute stuff. What is y sub 2? Y sub 2 is 8. What is y sub 1? 6. What is x sub 2? 3. What is x sub 1? 4. Therefore, 8 minus 6 is 2, and 3 minus 4 is negative 1. Therefore, my slope is negative 2. Hands if you got that. Okay, good. From there, we substitute values in here, negative 2, and we can pick either point. Hands if you pick the first point. Hands if you pick the second. Okay, I still have some people that didn't even raise your hand. Once again, who picked the first point to substitute? Second point. Okay, I'm going to go with the first point. So we substitute 4 for the x and 6 for the y. We solve for b, so this is 6 equals negative 8 plus b. So therefore, plus 8 plus 8, 14 equals b. So my equation in slope-intercept form is y equals negative 2x plus 14. Hands if you got that. Okay, good. From there, a line parallel to that one. Y equals, what does that, the slope have to be? Negative 2x. And it doesn't matter what the y-intercept is as long as it's not the same. Plus 23, Michael Jordan. I made a mistake where? Supposed to be positive 2? What is 8 minus 6? And what is 3 minus 4? What is 2 divided by negative 1? Okay. Let's go to a perpendicular line. Perpendicular. Give me your perpendicular line, David. David, perpendicular line. Jason. 1/2 x plus 23. Hands if you agree with that. That is correct. From there, we need a standard form, so we get the original one. What was the original one? Y equals negative 2x plus 14. So then to make it standard, we add 2x, We get 2x plus y equals 14. Let's see. Is it standard form? Ax plus by equals c. Yes, so therefore A is 2, B is 1, and C is 14. Hands if you got all that by yourself. Very good. Bam, from the corner. Let's go. Anyway. All right. So, we good? Let's go to problem number 2. Study guide. Get that in front of you. Problem number 2. Yay. We finished problem number 1, Julian. In 45 minutes. Yay. All right, here we go. So, it says, graph the line of the equation described by the equation 5x plus 5y equals negative 10, 3 different ways. And I label each way using a table, using the intercepts, or otherwise known as the cover-up method, and using what? Slope-Intercept Form. So, by looking at it, look at it, guys. Which method could we use right away as is? Cover. So I want you to write this down here. Write it down there. Negative 5x plus 5y equals negative 10. Negative 5x plus 5y equals negative 10. All right. So, cover-up method. I'm going to start with red, and I'm going to cover up the y value. So from far away with your thumb, cover up the y value from the screen, or right there, you can cover it there. So if we cover up the y, what do you see? So I'm going to write negative 5x equals negative 10. Guys, in this work, I need to see. If you don't have any work, I'm not going to give you any credit. Let's solve. Divide by negative 5, divide by negative 5. X equals 2. Am I done? No. I want you to write this as a coordinate, 2, 0, and that's my x-intercept. I'm done with that one. I'm going to cover up the other variable. So with your pencil or your thumb, you can cover up the x. What do you see? So that one we do over here, 5y equals negative 10. And let's solve for y. Divide by 5, divide by 5. Y is equal to negative 2. Am I done? No. Coordinate, 0, negative 2. That's my y-intercept. Everybody ready? Let's plot those 2 points. One of them is 0, negative 2, and the other one is 2, 0. I'm going to do the y-intercept first. 0, negative 2. 0, negative 2 is down here. What is the other one? X is 2, 0. 2, 0 is right there. Get your index cards. Sketch your line nice and straight. Make sure it goes through the whole coordinate plane. Arrows at the end. Are we there? All right. Next, we got that one. I want you to go to the one on the right where it says Slope-Intercept Form. And I want you to write the same equation again. Let's write negative 5x plus 5y equals negative 10. Is this in slope-intercept form? No. Tell your neighbor what you need to do to make that in slope-intercept form. Oscar, what do you need to do? Plus 5x plus 5x. We get 5y equals 5x minus 10. And then divide by 5 both sides. So y equals 1x minus 2. Hands if you got that. All right. Can we graph that using the y-intercept and the slope? Yes, let's do that. We're going to start where? At negative 2. So circle your negative 2. Plot your point at negative 2. I'm going to do this one in red. What is my slope? 1 up, 1 to the right. So we go 1 up, 1 to the right. Plot your point. Do it again. 1 up, 1 to the right. Plot your point. Do it again. 1 up, 1 to the right. Plot your point. Do it again. 1 up, 1 to the right. Plot your point. Graph your line. Remember, the more points you make, the straighter your line. Okay? Now, what do you guys notice? That line to the other line? It's the same line. We're just using a different method. Okay? All right. Are we there so far? Now, check this out. I'm going to zoom out really quick. Now, we're done with the intercepts or cover-up method. We're done with slope-intercept form. When you get done with this, check this out. Do the table at the end so that we can use this equation over here. Does that make sense? You already did all the work. Why do it again? Does that make sense? So check this out. So what you're going to do, so you can remember, I want you to draw a line and point it to here so that you can write your equation y equals x minus 2 right there. Okay, now I'm going to zoom in over here where it says table. I wrote my equation. That means I'm going to make a table here. X, y, and we got negative 2, negative 1, 0, 1, 2. That's the domain I want you to use. Now, if you want to use more points than that, that's fine. But I need those at least. Okay? Okay, now that we have our equation, what is our first value that we're going to substitute in there? So that goes here. So we write negative 2 underneath there, and we write y equals negative 2 minus 2. What is negative 2 minus 2? That goes right there. We're done with the first value. So with the next one, I'm going to write y equals, what is my next value? Negative 1 minus 2. What is negative 1 minus 2? Negative 3. So that goes right there. What's my next value? Y equals 0 minus 2. What is 0 minus 2? Negative 2. That goes right there. Do you need to show me more work? No, at that point, you just need to look at the pattern, fill in the rest. What is my next value? Negative 1, and the last one? 0. All right, let's plot those points and graph our line. There he goes. I zoomed out. There he goes. Negative 2, negative 4. Negative 2, negative 4 is right there. Negative 1, negative 3 is right there. 0, negative 2. 1, negative 1. And 2, 0. Get your index card, graph your line. What do you notice? It's the same line, different method. We got this? Okay, now check this out. On paper, you're going to do, right now I'm going to give you a new equation so you can do the process for these two and this, but you're going to use these same these coordinate planes to graph your new line. Everybody understand? All right, so before we get there though, everybody stand up really quick, stretch. All right, as you were. Okay. So, focus please. On your blank sheet of paper, write example 2Q. And you're going to write graph 3 ways. Here's your new equation. 3x minus 3y equals 15. So for the work, label it A. I want you to do that one by intercepts. B, you're going to label that and do the work. Show me the work for the Slope-Intercept Form. And for C, you're going to write table. So on your blank sheet of paper, do the work for that, but then you're going to graph on the study guide, okay? Okay, I'll give you some time for that. Ready, copy, and go. Let's see what we got. I said usually we start with intercepts, right? All right, so let me move this out of the way right here. So, 3x minus 3y equals 15. If I cover up the y, what do I see? 3x equals 15. Divide by 3. X equals 5. Or 5 comma 0, which is my x-intercept. Let's see hands if you got that far. Okay, good. From there, if I cover up the x. Now, some of you did the opposite, that's fine, but as long as you get those same points. And then I see negative 3y equals 15. Divide by negative 3. Y equals negative 5. What does that mean? 0 comma negative 5, and that's my y-intercept. Hands if you got that. Okay, good. So the graph, negative 5y would be down here. 5x would be over here. So your line should look something like that, nice and straight like mine, yes? Okay, good. Just using 2 points, is that correct? All right, let's go with slope-intercept form. 3x minus 3y equals 15. Focus, please. So we subtract 3x. Negative 3y equals negative 3x plus 15. Divide by negative 3, divide by negative 3. Y equals x minus 5. Hands if you got that. And of course, we start with negative 5, which is down here. We use the slope 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right. And then your line, should be going through those points. Hands if you got something like that. Okay, good. And the last one using the table, what did I say? Since we already did the work for this one, you just rewrite this same equation, y equals x minus 5. Our table is x, y. The domain's the same. -2, -1, 0, 1, 2. And my first value is -2, so y equals -2 minus 5. Y equals -7. That goes right there. Next value. Y equals -1 minus 5, so y equals -6. That goes right there. Next value, y equals 0 minus 5, so y equals -5. That goes right there. Do we need to show the other work? No. So this is -4 and -3. Yes. Say that again? But did you do these? Okay, here goes again, guys. The domain I want you to use is this one. If you want to add more, do so. So if you used -100, -99, -98, -97, ... as long as you use these 5, that's fine. If you want to show the work for those, that's okay. But I want to see the work at least for 3 of these and use this domain. Yes? Because if not, if you use those other ones, how are you going to graph this if your coordinate plane on the graph, it only gives you up to so much? Does that make sense?
Yes, Mr. Q.
All right, good. Show me with your fingers how comfortable you are graphing 3 different ways. Yes, let's go from the corner. Now, is it helping going over the whole thing again? Yes, right? Okay, yeah. To what? Okay. Go to study guide number 3. Yeah, we finished with number 2 already. All right, here we go. It says, solve that system by graphing, substitution, and elimination. Let me do this really quick. All right. Look up, please. Let's start with graphing. Ready? Focus, please. Look at the top equation. Which method can we use to graph that one? Tell your neighbor. As is. Everyone. Cover up. So watch. I'm going to go and I'm going to do it on the left side. Do you have enough room on the left side? So watch. If I cover up, I'm going to cover up the x first. Then I'm going to use red. If I cover up x, what do you see? Y equals -2. And in parentheses, I'm going to write 0, comma, -2. That's my y-intercept. Then I'm going to cover up the y. What do I see? I see 2x equals -2. Divide by 2. Therefore, x equals -1. What does that mean? -1, comma 0. X-intercept. All right, let's graph this line first. My y-intercept is 0, -2, which is down here. I'm going to do this one in red. And -1, 0, which is right here. Sketch your straight line. Make sure it goes all throughout the coordinate plane. Make sure it crosses the whole thing. There it is. Let me zoom out. All right. Let's graph our second equation. Let me zoom in so you can see it. What method can we use for the second equation? Tell your neighbor. No. What method can we use for graphing the second equation? Okay. Stop. You guys are not understanding what I'm saying. The first method of solving a system is by graphing. The problem that we just did earlier, problem number 2, we graphed 3 different ways. So look at these. I need to graph these 2 equations. I already graphed the first one using cover-up method. I need to graph the second one. What method can I use? Slope-Intercept Form. That is correct. So where do we start? At -5. I'm going to do that one in blue. We start at -5, and what else do we need? The slope, 1 over 1. So with that information, I start at -5. My slope is 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right. Now that I have those points, let's graph our line. Nice and straight like mine. Okay, let me zoom out. Should look something like this. Am I done? No, they're asking us to solve. How do we solve? Tell your neighbor, what is the solution to a system or any system of linear equations? Let's see. Andrew, what is the solution to any system of linear equations? The intercept, where the 2 lines intersect. So right away, you're going to plot a big point right there. You're going to label it. What is the coordinate for that point? 1, -4, and that's my solution. We're done with one method. Okay? Let me zoom out. What is the next method that you want to do? You want to do substitution or do you want to do elimination? Substitution? All right, let's do substitution. Rewrite the system right here where it says substitution and rewrite it again under elimination. All right, there's my system. Let's solve this by substitution. Make a note on top. What is the one thing that needs to be true in order for me to start solving by substitution? What needs to be true? You need to solve one equation, comma, for one variable. That has to be true in order for us to solve by substitution. Look at the 2 equations. What do you guys notice? One of them's already solved, so they already did step 1 for us. So let's see. What is y here? X minus 5. So on the first equation, instead of writing y, what am I going to write? X minus 5. So watch. I'm going to write 2x plus, and instead of y, I'm going to write x minus 5, and then equal to -2. All right, let's solve. Here we go. This is 3x minus 5 equals -2, plus 5 plus 5. Oh, this was -2, sorry. Then we get 3x equals 3, divide by 3, x equals 1. What do I do from there? Substitute. I don't like the word plug in. It's not like we have Glade smell pretty things that we plug into the wall. We substitute. So we substitute into this equation, and instead of x, we write what? 1. y equals 1 minus 5, so y equals negative 4. So let's see. Solution is 1, negative 4. Did we get the same thing that we did on the graph? Let's see. 1, negative 4, yes. So let's write solution. If we get two that are the same, then we write solution because that's how, it's kind of like a check. We checked it already by a different method. What is the next method? Elimination. So let's do elimination. All right, so what needs to be true for solving for elimination? Three things need to be true before we begin. Tanner. Okay. Jada. Has to be aligned. Oh, you said that? Okay. Are all of them aligned? No. Which one needs to go? So the x, so we subtract x. So my new equation is negative x plus y equals 5. And I bring down the, is it 5 or negative 5? Negative 5. I bring down the other equation, and I write it down here. 2x plus y equals negative 2. All right, so first thing is align. What is the second thing? Very good. Isolate. Iso the constant. Is the constant isolated for both? Okay, once again, are both constants isolated? Yes. Okay. What is the third thing that needs to be true before I start elimination? Opposite coefficients of one variable. All right. Do we have opposite coefficients? No. Which one do you want to eliminate, the x or the y? Okay, let's eliminate the x. To eliminate the x, tell your neighbor what we need to do, please. Very good. We multiply the top one times 2. Distribute. So we get negative 2x plus 2y equals negative 10. Let's solve. This is cancel. This is 3y equals negative 12. Divide by 3. Y equals negative 4. What do I do with that? Substitute into one of the two. Which one do I use? I'm going to use the top one, this one. 2x plus y equals negative 2. 2x, and then instead of y we write negative 4 equals negative 2. Plus 4 plus 4. 2x equals 2. Divide by 2. X equals 1. Therefore, my solution is 1 comma negative 4. Did we get the same thing as the previous one? Yes. And as the previous one? Yes. And that's how you solve a system 3 different ways. So with your fingers, how come you are with solving systems 3 different ways? Got some 5, 5, 5, 5, 5, 5, 5, 5, 4s. Okay. I think we got this, yes? One more? All right. All right. Since we did plenty of practice that in class with the warm-ups, you should be good with that, yes? Okay, before we continue though, turn to your study guide, the last problem on the study guide, last problem. It says, fill the Freyer model for systems of linear equations. I want definition, I need one example, one non-example, and 2 hashtags. Okay? Copy that and go. I'll give you some time for that. Ready, go. All right, here we go. Definition. Let's see, someone from over here. Ivan. The set of 2 or more linear equations with the same variables. Hands if you got that, or something like that. The set of 2 or more linear equations with the same variable. At least 2 variables. No, not at least 2 variables. Same variables. If you say variables plural, it means it implies. It says the set of 2 or more linear equations with the same variables. Example, CJ, example. What's that? No, that's it. That's the definition. That's the definition. All right. Example. Ryan. (3x plus 1). What? Minus 11y. Okay. Okay. Hands if you agree with that? Yeah, 2 variables each in their linear equations. All right. Can you give me a simpler system? Skylar, go. X plus y equals 10. 42x plus 10 equals y. Hands if you agree with that? Yes. 2 variables, an equation, yes. Non-example. Justin. Six y plus x equals 2. Why is that a non-example? Bam, let's go from the corner. Hashtag, the other Justin, go. Not you, the other Justin. What is it? 2 equations. All right, another hashtag. Enrique. Same variables. Hands if you got something like that. There you go. And do you get full credit for this one already? No, you needed to write system of linear equations. All right. So for the first part of the video, I'm going to stop here.